Hello, we are talking time and place and being able to talk about time and place to a global community. When we talk about that, we might make observations that are qualitative or quantitative. For instance, for the qualitative, we might talk about the shape of those clouds that are on the book, the text cover that you have right there. That's a very famous photograph. Or you might make quantitative measures of the altitude of those clouds. We need to record the time and place that we make those observations, and we need to record it very specifically so that everyone around the world can know and can rely on our measurements. Let's talk about how we talk to the global community in meteorology. All meteorologists, all pilots, all doctors, all use a 24-hour clock. There's one right to the right for you right over there. And we use a 24-hour clock because AM and PM are so confusing. When we talk about 2 p.m. at CCM, we can actually talk about 1400. You can see on the clock over there, 1400 o'clock. And when we talk about it, we describe it as 1400. That's the way we look at it. We might say 1400 Eastern Standard Time, but Eastern Standard Time in the US is confusing to a meteorologist in Bulgaria, so that we have learned to work with that 24-hour clock with one reference point around the world. Let's describe that a bit better. That one reference point around the world has 24-hour time zones that span one entire Earth's rotation. And each of those 24-hour time zones is coordinated to one meridian of longitude that happens to go through Greenwich, England. On its way from the North Pole to the South Pole, it goes through Greenwich, England, and it goes through part of Africa as well. And you might say, Greenwich, England. Why Greenwich, England? That was actually decided in 1895, and Europe won that one. It was coordinated to coordinate train schedules throughout Europe, and the U.S. adopted that as well because they were looking at telegraph messages going back and forth at that time as well. So we needed really precise time. That Greenwich Mean Time, which was known as GMT at the time, has now been retitled as Universal Coordinated Time, UTC time, and the same thing is known as Zulu time. So each of those three measures are known as the same thing. You might see a 24-hour measure as UTC after the 24 hours, or GMT, or Z for Zulu. They all mean the same thing. So let's talk about it. If we talked about midnight in England at Greenwich, midnight would be 0000 hours. Okay, 00:00 hours. And we in New York City are not at that same time. We're actually 5 hours in back of that time when we are in our regular standard time. In other words, when we're not in daylight savings time. We are 5 hours in back of London. So what would be midnight in London is actually 7 p.m. in New York City on our standard time. If we took a measurement at 7 p.m. in New York City, we would say we're taking that measurement at 0000 Zulu time. And the meteorologist in Bulgaria would be able to understand that everything is coordinated to Greenwich time. So a 7 p.m. measurement for temperature or for precipitation in New York City would be recorded for scientific purposes as 0000 Zulu time. or 0000 GMT time, or 0000 UTC time. Let's go into that a little bit more carefully. Now, we explained that at the 7 p.m. equals 0000 Zulu time in London. But then we got to start thinking about daylight savings time. And the U.S. does wreck this up for much of the world. I got to tell you that. From March to November, in the U.S., in most of the U.S., but not all of the U.S., we skip forward 1 hour. We do that because we believe it saves energy by conserving that hour of daylight till after work. That has never been proven, but it is tradition by now. So at this particular time, during daylight savings time, we are not 5 hours in back of London. We are actually 4 hours in back of London. And as you can understand, there's a lot of computer apps that do this for us so that we avoid the confusion of daylight savings time. But we know that the 24-hour world clock really does eliminate a lot of confusion because all times are recorded as GMT or Zulu time. Think about that for a bit, work that around in your brain, and you should be aware of that. You'll have an exercise for that in your short assignments for the week. When it comes to place and announcing the exact place where that photograph was taken on that road, which I believe is in Oklahoma, we really need to know a certain latitude and longitude. Let's go over latitude and longitude for you. When we talk about longitude, we are using the same devices for longitude and the same prime meridian that we used for GMT and UTC and Zulu time. In other words, the prime meridian goes from the North Pole through to the South Pole, and it's still at 0 degrees. It's still the beginning place for measuring east and western locations. In fact, the world is divided into 360 degrees longitude that covers one Earth's rotation around a polar axis. The prime meridian goes from the North Pole to the South Pole and up to the North Pole again and divides eastern and western hemispheres. New York City is in the western hemisphere, and the western hemisphere has 180 degrees of longitude to it. New York City happens to be at approximately 77 degrees west longitude. How are you going to remember that longitude goes from North Pole to South Pole? It goes the long way from North Pole to South Pole. You can also remember that longitude is a meridian by thinking about the old song, "Merrily, Merrily We Roll Along." Merrily, as in meridian, and longitude, going the long way around the world. So I hope that helps you a bit. Let's get to latitude. Latitude is actually 180 degrees from North Pole to South Pole. The equator divides that area, and the equator divides that 180 degrees into 90 degrees of parallels from the equator to the North Pole and 90 degrees of parallels from the equator to the South Pole. So in other words, the equator divides it into southern and northern hemispheres. And when we name a particular place like where that cloud was in Oklahoma, we named the latitude first and the longitude second, so that New York City happens to be at approximately 42 degrees north and 77 degrees west. So 42 degrees north latitude, 77 degrees approximately west longitude. How are you going to remember that mnemonic? Well, remember that latitude goes horizontally in parallels. Latitude is horizontal. It's like flatitude. So I hope that reminds you that rhyme, latitude, flatitude. I hope that reminds you and helps you out. Latitude and longitude is absolutely essential for proper positioning, especially of storms. Let's take a look at this hurricane down here. We can really nail the eye of that hurricane right to approximately, let's do latitude first. Latitude is flatitude, north and south. This is at approximately 13 degrees north. Then we do longitude. This is at approximately 116 degrees west longitude. We can really nail that so that we can warn other people of the position and of the movement of that hurricane. I hope this helps you out, and I will see you on the next video.